Hello, my name is Jarko Vihriälä. I work as product manager here in the Qt company. My areas of responsibility are graphics, UI and the Qt Design Studio. You might have seen me talking about Qt and 3D graphics already during the conferences held this spring. It was during the times when we released the Qt 6.1. Back then we told that after the summer, some of the tooling for these 3D features will be made available. And this is what Qt Design Studio 2.2 is all about. As you know, one key benefit of the Qt 6 is to have a unified graphics pipeline for the 2D and 3D. This means that your 3D objects and controls are seamlessly integrated with the rest of the user interface, as the Qt Quick itself is rendered using the same scene graph. And now, with the Design Studio 2.2, you can unleash the power of the Qt 6, because Qt Design Studio 2.2 not only supports the existing Qt 5 for the previous projects you might have, but it also supports Qt 6, so you can pull in all those 3D features we talked about in the past and enable them in your user interface projects and tweak and control the effects from the Qt Design Studio with little or even no coding needed. Qt Design Studio is a tool more targeted for the people that are not that technical, so you don't need extensively C++ or Qt itself. Actually, it's enough to understand the QML scripting language which we use. That's how all the user interfaces produced by the Qt Design Studio are built. It's just QML and maybe some JavaScript in between. The syntax of the QML is really straightforward and easy to understand, and the way Design Studio generates you the QML code is so that it is really human readable and it doesn't need to be expert to understand what reads there. The QML itself could be a story of its own, but let's just say that it's a scripting language and similar to all of those JavaScript-based languages that you find currently out there. But before we take a deep dive in practice with the Design Studio 2.2, let's briefly look at what the Design Studio is about. When Qt Design Studio was introduced, we wanted to offer a complete toolchain from designers to developers to lessen the burden what happens when the user interface is designed and in some cases later coded again by the development team. By using our solution, you don't need to re-implement the user interface anymore by coding, because the Qt Design Studio outputs the user interface as a kind of add-on to the application itself. So the UI developer doesn't need to modify extensively the code, tweak those objects 3 pixels to the right, etc., when the real implementation starts to differ from the output from the designers. Qt Design Studio delivers the full functional UI, and it can be used even to validate according to the interface specs. When the Design Studio 1.6 was introduced, it had little or none real 3D capabilities, because we were still in the process to implement the Qt Quick 3D, which is the rendering engine behind the Design Studio. Already with the previous version of the 2.1 and 2.0, there was some 3D stuff already implemented, but now with the 2.2, you can actually implement many of those 3D features, including the 3D particles and instancing, directly from the user interface. So you don't have to needlessly code that much or at all. And the good thing is that you don't need to implement UI user interface effects with shaders. You can just drag and drop things from the component gallery and then modify them with properties, and if that's not enough, you still have the access to the QML code. Like mentioned before, benefits of this Qt 6 architecture is to seamlessly combine the 2D and 3D in one scene. We will see that in a couple of examples later on. Together with the 2.2 Design Studio, we are shipping the Qt 6.2, which has the latest implementations for the Qt Quick 3D, including many different particle effects and morphing animations, instancing, just to name a few. And the bus doesn't stop there. We still continue implementing them. Already in Design Studio 2.2 and Qt 6.2, you can have real-time reflections. We don't have the API there in place, but the functionality is there, so it can be utilized from the Design Studio. Qt Design Studio is not a rival implementation for Figma or XD or any of these modern prototyping tools and asset creation tools. Instead, we complemented that story. If you have been using Figma or Adobe XD, you already know that it's really cumbersome to get anything out but from PDF or HTML from that tool. We offer a plugin interface that you can export your project out from that, let's say, content creation tool into Qt Design Studio, where you can add timeline animations, pull in 3D stuff. Well, as you know, with these UI creation tools, they are usually just only 2D, and you cannot have 3D as a kind of easy way. So with Design Studio, you can have that 2D user interface creation and then pull in those 3D effects, which you have done with your Blender, Maya or 3D Max, and combine the fully functional user interface. And now the technical artist or the user interface designer can actually validate that the project runs nicely 30 to 60 frames per second, even on the target hardware, which is not possible with the other tools. What is the benefit here? Well, you don't have to go through the development team and make them integrate the user interface and then together with them test on the target hardware and realize that, okay, the complexity of the 3D models is too high, so we need to drop the polygon count and lose some materials. These steps can be already done in the design phase, thanks to the hardware prototyping functionality of the Qt Design Studio. And once the user interface design phase is ready, the user interface is fully functional and can be integrated. So it can be transferred through a zip file or a Git repository to the development team. And thanks to QML, it's the structure of the user interface project is really compact. There's not much extra files and scattered small fragments here and there, but everything has their own QML component, and the assets that they connect have their kind of corresponding files there, but nothing else. So it's really clean and simple on the structure side. Here we describe the main features of our new graphics engine. And what we have is actually something that was given to the Qt company some time ago by a well-known graphics company, and we have built our offering on top of that. But instead of having a loosely coupled graphics engine, which isn't kind of a part of the framework, the Qt Quick 3D actually is really tightly integrated to Qt and therefore utilizes nice synchronization mechanisms from the Qt Quick. What we will have here is that we have the greatest feature of them all, of course, is the 3D particle system. And the benefit here is that you can have realistic weather effects. You can do water, ice, fire nicely with the particle system, and you don't need to have shaders at all in the picture. Then you can have instance rendering, meaning that when you implement a scene which has multiple similar objects, you have just one instance uploaded to the graphics processor, to the GPU, and then you just refer an instance out of it. We will look at one example of this as well later on. Like mentioned, we have the real-time reflections, and we have an automotive demo, which is probably shown in some other stream during this conference, and you will see a real-time reflection happening there. So all in all, it's nicely packed. It already has good set of features to give our dear competition run for their money, and we continue to improve. We already have stuff in the pipeline which will make the Qt Quick 3D and the Qt Design Studio a really good choice for the future user interface implementations. Okay, so here we are in our Qt Design Studio, and I already opened the project which is containing this example. And first we will look how the instancing or instance rendering is done with the Design Studio. So on my right here I have the scene graph navigation. So basically there's all of these objects what we have here are based on the same model, and this is, like it says here on the property window, that this is an instance of a component. If I want to, I can edit the base component, which means that all the changes I do for the component will be made available for any of these instances. What has been done here is that there's a grid of the cubes on a 3D scene, and they are tied to various animations on the timeline. So when the timeline is moved here, then various things happen there on the scene. Thanks to my recording software, the OBS, my Mac is having a slight difficulties to render this nicely. Okay, so when I want to see this whole scene in action, I don't actually have to build or compile anything. I just do a QML preview, because if we look at the code, this would be our file. We import some stuff from the Qt assets themselves, and then the rest of it is just, standard magic QML. And if I edit something on the editor, the changes are reflected immediately on the QML code. Let's wait for the user interface to come back. Here we go. All right. So I'm doing QML preview, and I'm running the scene, what you see here. And as you can see, there's some movement and some color transitions based on the HDR map that was part of the project as well. And to do this, we didn't do any magic on shaders or have some kind of things to do, you know, C++ magic behind. It's all pure QML. There you have it. Alright, now we want to play around with the particle system a bit in Design Studio. And what we have here is something already made. So we already have some scene elements and a particle system enabled on our 3D scene. This is done just to save time. If we would go from scratch to the end of the presentation, it would take more than 15 minutes. Let's just fire up the QML preview so you can see that this is our sphere. This actually also is done using a particle system, so we have different particles being emitted. As you can see, there's sparks flying around. But what we want to do here is we want to light the globe on fire. Okay, let's go. First I want to pull in my 3D particle from this component gallery, and I want to use trail emitter. I attach it to my particle system, just, you know, pulling it in. I also need a vector direction element for my trail emitter. Here we go. And because my flames are done with the sprites, I'm using sprite particle like so. Now we start to modify this a bit, but first we want to have a real image on the flame. So I go to the standard Qt Quick 3D elements and pull in the texture for the sprite particle, like so. And I just attach it to a source file, which is the flame 01. Nothing happens. Remember, you probably have seen this 6.1 video from this spring during the DevDes conference, where we had this live coding, and so this QML preview on the Design Studio is pretty much the same thing. Okay, so I modify this sprite particle a bit. I change the blend mode to screen. I attach my texture as the sprite, and then I go to the max amount, put here 10,000. I don't want to have a huge sized particles, so I put this to this 3. Color variation with something we will deal, so I just put here 40. Okay, then we have the fade in, fade out. The algorithm is just fine, but we change the duration like so. So roughly half a second and then 1 second here. And we don't touch anything else. Okay, good. Then we touch slightly the vector direction. The Y is already off the scale. It's our flames would be flying all over the place if they would be having that setup. And because we want our flames to circle around, we want to put some variation to all of these parameters here. Okay. Then the trail emitter itself. Okay. This is part of the particle system. Okay. And we are following a sprite particle, which is one of those already defined here previously. Our velocity is the vector direction, which we defined here. And the particle is the sprite particle 1, which we introduced here. The emit rate is 0, so nothing is running. We put 150 and we put 1400 on the lifespan. So you can already see something happening here. I want to put this a bit higher, so we will have more this kind of bigger sized flames here, and having this running here like this. Okay. Then we want to have the rotation for the flame element as well set to like so. Okay, but as you can see, the white thing there isn't nice. So we are talking about fire, so we definitely want to have fire. Okay, so that was a basic steps just to add particle effects into my scene. So if there would be some kind of heat element and I want to show fire, this is basically how you would do it. All right. There's been a lot of talks about this merging the Qt Quick itself with the Qt Quick 3D and having this tight integration there. So why don't we just introduce animation to the picture? So I pull in a number animation and I go from 0 to 360. Interesting. There. Then my animation target is the whole particle system, what you see on the screen. And this is something a bit annoying, but you have to, just scroll until you find it. So this is the ID of my particle system. So it's connected to that. Here is the only thing you need to write. So what we have done is that we added flames on our sphere, and now we are introducing animation to the scene. And this is the first point where we have to write some logic. And we are rotating on the y-axis. Loop -1, meaning that it's infinite. And one turn of the globe takes around 20 seconds or so. We don't change the easing curve. We have an easing curve editor, so I could use some weird stuff. And I can even twist these angles here, but let's not go there. Okay, so now our number animation is connected to the particle system. We have the Euler rotation.y typed here. So when I click running, the sphere and the flames should start rotating. Voila! And it works. Okay, this was just basic examples how you can play around with the Qt Design Studio 2.2. And it's out there, it's already released, so you can go to the qt.io webpage and download your evaluation copy. If you have a license already, then you can get the real deal and just implementing your next generation user interface. That's it. Thank you.